Let's write some code. In the previous video, we discussed this diagram, this sketch, crazy little sketch, and we are now going to put this into action. So let's do it. Let's do it. So let's get this set up here. Close all. Start fresh. Okay, so we're going to be building a use case. So let's get into our sources. We have a spot called use case. Nope, that's sandbox. Use cases. Here we go. We're going to have one in here called drag. What do we call it? Drag, tape, body. Test. TS. And we're going to also do a drag, tape, body.test.ts. All right, now let's get these two guys over here so we can kind of look at them. Okay, drag, tape, body. I like to make my functions, or I like my use cases to be functions. They don't, hopefully they don't need a state is what we're shooting for here. So, okay, so let's do that. So export, and actually take this. No, let's do it without the factory first. And then we'll talk about making our use cases into a factory generated function and why we do that. But first, let's just get this guy going. So we're going to export a function called drag tape body. And as we identify, we need the ID string. This is the tape we're dragging around. And we need the drag distance, drag delta. And that's a vector 3 entity. It's one of our vector 3s. Here we go. This is not going to return anything. It's a function. We're going to need our entity. So we're not, when we click on this mouse, or when we click on this tape body, we're gonna be able to identify the tape body because of we're gonna add an attribute to the mesh, and that'll tell us that this is a tape body. When we do that, we know the ID, but we don't actually have the tape. So we need to get the tape itself from the repo. So we're going to do this. We're going to need the tape measure repos called tape measure repository. We're going to need that too. Okay. So let's set up. That's enough, I think, to get this thing compiling. So let's come over here now. Let's make our test rig. We're going to do a function called make test rig, and we know what we're going to need is we're going to need we need to make a tape. So constant tape is going to be equal to make tape measure, and let's give it an ID of just tape 1. And we're going to just attach it to a string because it wants that. It wants to be attached to something. Doesn't really matter. Let's go ahead and set our positions. Maybe we should come over here and think about our sketch or our testing bed here. So if we come down over here, let's see if I can draw without pulling this thing all the way out. Here we go. So over here. So we want to think about our test. So let's get a black pen. So over here this is going to be 0, 0 for our test, and let's start our tape at 1, 1, kind of like what we did on the other one. So this is going to be PS is going to be 1, 1, and then let's just make it funky. Let's make it a little diagonal guy going up here. So we're going to go over 1, 2, 3, 4, 1, 2, 3, 4. We're going to go to here, which puts P end at, what is that? It's 5, 5, comma 5. So this is how we're going to build our, so this is origin down here, and here's our PS, our start, our position to start, and our position to end. So that's how we're going to build this. So 1, 1, and 5, 5. So let's do that. So tape dot start point is going to be make vector 2 dot, and that's going to be a 0, 0, no, 1, 1, and tape dot start point, no, end point is going to be make vector 2, and that's going to be, what did we say, 5, 5? Did we say 5, 5? Yeah. So that makes our thing 4 over and 4 up. And then we need to we need to make our repo constant tape repo equals make tape measure repo, and we need to add this tape constant add tape. No, tape repo add. What? Oh, we can't do a constant in front of that. Tape repo dot add, and we're going to add our tape. Okay, so we've set up our tape in the initial position and all that stuff. We're going to need to drag. Oh, why'd you get unfocused? Let's do this. Blurry. Anyways, oh come on, focus. There we go. Not focusing very well. Okay, there we go. Okay, so now we got our tape. I think we have everything we need. So let's return our tape repo. I don't think. And our tape, because we're going to need to check the tape. So let's do this. So now test. What is our first test? Let's just drag a tape. We drag tape tape entity is ENT is drug as expected. All right. Drug, is that a real word? I think it is. Okay, let's get our tape repo and our tape. And that's going to be equals to make test rig. All right. Now, let's create our drag vector. So let's go back here. So here's our P, whatever, our P's. Let's make our world drag vector run from, we'll just pretend like we're not going to click right on the thing. That's just impossible to do. So let's just use this yellow line to make our drag vector. And then we're going to start it out here, and we're going to go up to here. Let's do let's make it 45 degrees. Well, no, let's just do here to here. All right, this is going to be our world drag. And so that's going to be 1, 2, 3 negative in the X. Y is going to be 0 because in the Babylon world, in the world coordinate systems, remember we're working in 3D coordinates, but we're not going up and down. We have set a plane at the 0. And then Z is going to be 1, 2, 3 in the Z. What, did I do 45? 1, 2, 3. I did do 45. Oh well, it's fine. Okay, so that's going to be our drag position. What this means is that this guy should become PE prime, should go 3 this way, and 3, 1, 2, 3 this way, right? Let me draw. So that means PE prime should equal in the coordinates of all this. I know we're switching between 3D and 2D, but what we should expect is it for it to go -3 in the X, which is going to be 2, 5 minus 3, and then 5 plus 3 in the Y, which is going to be 5, 6, 7, 8. So this is what we expect it to come out to be. So that's our test. So we're going to do a constant drag delta equals make vector 3, and this vector 3 is going to be, what was it again? -3, comma 0, comma 3. All right, now let's do it. So we're going to do drag. Oh, I spelled tape to body. Okay. Our ID is going to be tape 1. That's what we made up here. You can see that. And our drag delta, spelled that wrong too. And our repo, tape repo. All right, let's fix some of these misspellings. So we're going to do this drag delta, and then this we're going to drag tape body. That should There we go. Got that going. So if we did this right, we would expect tape dot endpoint x to equal, whoa, what happened? What did we say? 2. And expect tape.endpoint.y to equal 8, I think is what we said. Yeah, 8. There we go. Oh, we gotta get our test pointed at the right spot. So P is gonna be drag tape body. Now, should fail. All right, let's get it to fail. Let's get it to pass. So first off, we need to get the tape. So constant tape is gonna be equal to tape measure repository dot get ID. Then we're gonna say, and then note we could fail here, so we need to do a test for that. So test for bad ID. Okay, tape. Now we're gonna do. Okay, so we got our drag delta, which is in 3D. So let's go ahead and convert that constant. Drag delta 2D is going to be equal to make. We're going to make our vector 3, and all we got to do is pull out the right values. Remember, we're just ignoring the y because that's the up down in Babylon, and we're thinking everything is planar. Yeah, that's right. So we got our drag delta dot x and our drag delta dot z. We ignore y. What happened? Why don't you like this? Oh, we were making a vector 2. All right, now we're just going to do constant new position, and that's going to equal the new position is going to equal the tape dot endpoint, and we're going to add our drag delta 2D onto that, and then we're going to set that. Now we're going to do tape dot endpoint. It's going to equal new position. That should pass. Hey, look at that. All right, let's get into a little bit of constraints. I know for a fact that just because of the way we're building our tape measure, we can't go longer than 25 feet. So we need to do a constraint at this point. So let's go ahead and apply that constraint. Well, oh, wait, before we do that, let's test for bad IDs. So test, we're going to expect if trying to drag a tape with an ID should throw an error. We tend to do errors in the entity. We do errors in the PM. Do we do errors in the PM? Nah, maybe we just catch the errors in the PM. We catch errors in the controller, but we do throw errors in the use cases. So we're gonna do this. So we got this. We don't even need all this stuff. So we're gonna do drag tape. We're gonna expect. I guess we do need a repo, but we don't need a tape. And we're gonna say unknown tape. Go ahead and just grab our delta from up here. Doesn't really matter what it is because it should throw an error. Now we're gonna expect this to throw error. So that's going to throw because we don't have. Now I think the error should get percolated up because what's going on here is our get is actually going to throw our from our repo. The get's going to throw the error. So we actually don't have to write code. But what this does is it allows people down the road to read through our tests and understand why errors are being thrown and when they should, when we can expect an error to be thrown. So we know it's accounted for. All right, we're going to test limiting the tape length to 25 feet. What is that in inches? Let me do a quick check. Yeah, we'll just multiply. Okay, 25 feet. All right. So what that looks like is, let's just make our life easy. We already know we can do crazy angles. So we're just gonna set this up. We're gonna set our tape dot starting point is gonna be zeros equals make vector 3, no, this is a vector 2. It's gonna be 0. Okay. Set the end at 0 and tape dot oh geez, why are you doing that? Tape dot endpoint, let's just put it at 1 in the x to make vector 2. So it's super simple. It's got a point at the origin, and then it's got its end at 1 inch along the x. Now our drag is going to come in here, tape drag. And what we're going to do is we're going to do this drag delta. Now let's make this drag delta long. So again, we're not going to drag anywhere in the z. Let's just drag it right along the x-axis, and let's drag it out to well, let's find out how many inches 25 feet is. Convert 25 feet to inches is going to be 300. I almost picked 300 as my test. Okay, so let's drag the drag delta is not, let's make it 400. All right, we're going to drag it, and then what we're going to expect is we're going to expect the x to be clamped to 25 feet, so 300 meters, or 300 inches. And y is still going to be 0. Now, you know what I'm going to do, though? Just to make sure we don't screw up and add, do our math wrong, we're going to actually offset the point 1 and 1. That gives us a little bit of different distance from the origin, so make sure we're not doing math off the origin. Actually, we're going to do 10 and 10. Okay. Endpoint, we're going to make at 10 and 10 is, we're going to make the endpoint at 11 and 10. So we're going to have, it's the same layout. It's except the origin of the line is over 10 and up 10 inches. And then the end of the line is 1 unit to the x, 1 unit x from there. So that's what we got going on here. We're going to do our drag delta in the same direction. But this time we expect this to be 310, right? Because we've already offset 10 that way. So it's the length of the tape that is constrained to the 300 meters, not the distance from the start, or 300 inches. So that's why we're throwing that in here. And then we also expect y to still be offset up. So we're just going to make sure we're not fiddling with anything. Okay, so let's see what happens now. Okay, new position is going to be equal to that. So now we got to do this constant length, and that's going to be equal to, I'm going to do a little bit of math. We're going to do tape dot start point. No, we're going to do tape dot trying to just think through the vector math of this guy. What's the cleanest way to do it? All right, let's just keep it like this. So we're going to have our new position. Let's make this a lat, because we could change our new position. And so now we're going to do, we're going to call this, we're going to make a new vector. It's going to be the relative vector. It's going to be the vector from the start to the end, to our new position, our new end. Let's call this new end position. All right. Now our new end position. So now we need we're gonna have a constant called something like tape vector. I might come up with a better name in a second. Yeah, let's make it a better name. Tape vector for now. is going to be equal to the new end position subtract the tape dot start position. So we're going to subtract the new end from the start of the tape, and that gives us a long vector that runs the whole length of the tape. And what we're checking for now is if tape vector is dot length, I think there's a length or a magnitude, is greater than 300. No, we've hard coded that. We'll go back to that in a second. That's not great. If it's greater than 300, which is 25 feet, then we need to shorten. We need to just scale that vector back. We don't want to change its position. We just want to pull it in. So we're going to do this tape vector dot set length to 300. Because what that's going to do is it takes that vector, it doesn't matter which way it was pointed, and it shortens it to 300 when it was longer than 300. And then we can calculate the new position based on that. So now we've got new end position is going to equal to the tape dot start point plus or add the tape vector. All right, that's some, I don't know, that's some crazy vector math. Let's talk through that real quick just to make sure everybody's on the same page about what we did there. So let me get to here. So move it over here. We're going to just do some quick vector math. So what we did is this is 0 origin. This is the start PS. Doesn't really matter where it is. Here is the PE prime. This is the calculated, the new end position we've talked about. This is the vector we created called, these are all vectors, let's put a little hat on them. This vector is the new tape vector, right? That's this tape vector. And what we did was we looked at the length of this tape vector here, the L of that. And if L was greater than 300, we shortened this. So this vector became like, it got chopped to maybe here. So this got removed. Now we shorten this down to 300. And so now we still need to get our end position. And so now what we can do is we can do this is going to be equal to, so this is going to be our new PE. So this goes away. Our new PE prime is going to be equal to the PS, this vector down here, plus this tape vector that's been shortened. Right? So that's how we get to this point. So this is our new PE right here. So as the mouse has been drug off, you can imagine, you've clicked and you've drug from here out. And as you get over to here, your mouse is still over here, but the tape has stopped over here because we've limited it to 25 feet. Cool. So that's what's going on. That's that vector math. Let's flip back over. Okay, here we are. So did we pass? Hey, no, we shouldn't pass. We haven't done anything yet. Okay, so now, actually, we did pass. So we have adjusted the end position, so everything's good. Now, let's do a quick talk about this hard-coded 300. And that should tickle your spider senses, and you should be like, wow, that seems bad that we're putting that in there. And it is bad. This is a parameter that's essentially kind of set, but it's just in there, right? What if we need to do this same kind of math but somewhere else? We're going to drag the start position around, and we need to make sure that the end, still the thing doesn't get longer than 300. Well, now you got 300 in two places. Or actually, when we go to create the controller and the use case for dragging out a new one, we're going to need to stop that new one at 300 inches as well. And so that's a lot of places we're going to put this value for 300. And what if we come along and we're like, let's make it a 50 feet tape, and suddenly we need 600. Well, we got to go find all these 300s. It's just not great. So what I like to do is we have a folder at the very top level of our source called data. And in here I have app parameters. And this is a convenient spot to store these kind of like pseudo constants, I would call them. So we're going to call this longest tape measure, and we're going to set that to 300. We're going to just keep it in inches. All right. Now, one of the things about changing this guy is for it to be re-imported, you have to reopen your project. So I'm just going to close the project real quick, and we're going to open it back up. This is the wrong project. Let me get the right project. Open recent. Let's get a new window. Here we go. Get over here. All right, and we're going to do this layout foundation. Okay, now what we can do is we can go back to drag tape body, and we can do this import app parameters, METERS from ERS from, and then what do we got? Data slash, well, why don't you give me any help? Data. Why are you being like that? Usually it just brings it right in. There. Now we can do is we can just go ahead and cast that out so it's a little easier to read. We can do max tape length is going to be equal to app parameters dot longest tape measure. Here we go. And now we can do this. Perfect. Now we should also use the same parameters in our test, because if somebody were to come along and change that, let's get our test running. We shouldn't, whoa, what happened here? Something's funky. Let's do, there we go. I don't know what's going on down here. Okay, npm test, get this go. And we got these app parameters, and we got constant app parameters dot longest tape measure. Good. And then let's just put this into the test here. This is going to be max plus 10 because we started off offset up here. Great. Now let's get this test constrained a little bit to drag. Now one more thing we want to do is we also want to impose a short limit. And I've actually, as I was fiddling with these app parameters, I realized I'd already done that. Shortest tape measure is 12 inches. So we don't want the tape measure to be drawn smaller than 12 inches. So let's go ahead and set that up, get that all in here. So we're going to do limit. And let's make this a little more descriptive. The max take, but we're not going to tell it what it is because that's in that document or that JSON. And we're going to do the same thing here for minimum tape limit. Now I wonder if I'm going to mess up my previous test when we put this in here, but we'll figure that out in a second. Limiting the min tape length, and we've got the shortest. Let's rename this to there we go. All right, we'll keep our start point the same. We're gonna have to put our end point out there a little bit further. So let's put it at 50. All right, so now we've got an end. So this thing is 40 long. So if we make our drag delta to be 35 negative, that'll pull that end from 40 down to 15, or from 50 down to 15, which is only 5 away from our start point. And that shouldn't happen. So that we should end up with shortest tape length plus 10. Yeah, that's what we should end up with, because we start at 10. We have our shortest tape length, so we're bringing it back in. So, okay. How are we doing over here? What do we got for test? And we're going to do the same thing here. We're going to do else if magnitude is less than, it's supposed to be max. And this, we're going to do one for min. And there we go. Okie dokie. So if tape measure is less than this, we're going to set the length to that. And again, we're going to add it. So I think that should do it. All right, what do we do? Well, that's interesting. We got a crazy number, didn't we? Shortest tape length, min tape measure. Oh, 26. We're up on a different one. Okay, I was wondering if this would do it. So in our previous tests, we didn't really think about having too short or too long of tapes, essentially playing within the constraints. So we need to set up our tape a little bit different. Right now, they're not. It doesn't start out far enough apart, essentially. So we'll keep our start point at 0, 0. We'll put our end point at 50, 50. Pushes us out quite a ways. Now our drag delta is going to be, we're still going to go -3 from 50. So that should put us down at what? -3 from 50 should put us at 47. And 3 plus 50 should put us at 53. I think. Hey, there it works. Just got a little out of date. Turn on this light. That seemed to be dark. Okay. All right. Oh, that's way too bright. There we go. Okay, so great. I think we're about done with this use case, to be honest. Let's clean it up a little bit. Let's look at it for a second. So notice we've done some things here. We even though it just seems like, oh, you just got to set the end position of the drag of the entity, we've put a fair amount of logic. I mean, a little bit of logic in here, but it's all logic that doesn't have to be in all the controllers. None of the controllers have to worry about a constraint anymore. None of the controllers have to worry about erroring out. Well, the error is still going to come up. They don't have to worry about the math to go from a 3D to a 2D. They don't have to be concerned about the coordinate system of the domain. All it has to do is pass in a world vector that's a change in distance and an ID and the tape measure. Now let's talk about this repository issue. So you'll notice that in all of our tests, so this drag tape body is going to be called by a controller at some point. Currently, the way we have the signature set up, it has to pass in the repo. It has to do that for every time. So that means our controllers have to know about this repo. And that's kind of awkward. The repo, there's nothing special. It gets made once, and then it's forever out there for the entirety of our application. So I'm going to convert this into a factory, and we will make this drag tape body with the repo baked into it. So let me show you what I mean by that. So let's go back up here, and this is going to change a few things. We're going to no longer export this function. We're going to export a different function. We're going to export a function called make drag tape body. And in this one, we're going to pass in this repository like this. All right. This is typical factory stuff. If you guys need to understand factories better, we're not going to cover it in this video. But it's going to return this function called drag tape body. Oh, we need to return this. There we go. So now what we've done is we've changed the signature of what the controllers have to call. So they no longer have to worry about passing in and keeping track of the repositories of tape measures. They don't care about that. All they want to do is say, hey, I got this tape measure of this ID and I want to drag it this far. That's all they need to do. Okay, so this changes this thing over here. Our test repo has changed, or our thing has changed here. So what we'll do is we'll go up to our make test rig, and we're going to actually run the factory in our test rigger. So constant drag tape body is going to be equal to make drag tape body, and we pass in the tape repo here, and then we pass this function out like this. Now what we can do is notice we'll pass our function now. Notice how our function has changed. It's become simply the controller that's going to call this. They don't care. They don't have to know about this repository of tape measures. So let's continue doing this. All right. And here we go. We're almost done. All right. Cool. See, did that everything work out okay? And we no longer need the tape repo down here. None of these guys need the tape repo because it is baked in. In fact, we'll take it out of this. And clean this up. Perfect. All right, see if we pass. Great. Excellent. All right, cool. We're going to call this video closed. In the next one, we will build out the controller itself. All right.